but sometimes miss the point. So actually, I'd like to do something a little different because it's getting like end of the morning. So could you all stand up a moment and take a deep breath of air? That's good air. We just saw that. Okay, have a seat. Close your eyes. Imagine, if you would, in the old days, we had abundant water and trees, and they breathed out oxygen, and we had an abundance of fresh air. So you can open your eyes again. Kind of like what this picture shows. And then on what I call godologic time, about a few days later or several million years later, man came along. And we started dealing with our environment. And this is a shot from my office window, and it's gorgeous. But this is what we were looking at before. And then we added electric lights and motors and fires and so forth. So, you know, one of the things I like to explain and kind of to put us, I think of this a lot, to put myself in my place, is just remember that it took us 2,000 years to add wheels to a suitcase. So we might think we're all that, but not quite. So we then, you know, started once upon a time. We had lots of fresh air. And then along the way, we invented what I call the inside. I'm thinking of everything related to inventions now because my semi-retirement, I've started inventing stuff and actually moving them from the idea on. So, you know, about 10,000 years ago, we basically developed the inside and everything that goes with that. And I like to think that we did this because we were drunk, as opposed to just stupid. We're the only animals, species on the earth, our home, that is actively working to destroy it in lots of individual little ways. So, you know, I've been using this slide for a while, but ancient Chinese saying, humans dwell between heaven and earth. And we do, if you look at this little blow up, think of Beijing now with their air. So what I think happened is about 2,000 years ago, and maybe a little longer, a bunch of white guys in a college dorm were sitting around and they invented oil. Or they invent oil, but they invented how to get oil out of the ground, or coal, fossil fuels. And the first thing they thought of was, wow, this is a great idea. It's enough to buy several kegs. So they went out and bought some kegs. And from that time, we've been buying kegs. We've become addicted, and we've been having this great old party. And one of the things we're really good at as humans is screwing up our environment and then finding ways to fix what we just messed up. And the more we mess it up, the more innovative ideas we come up with. And we find we go around in circles a lot. So when we moved from shelter to indoor, in the old days, they used what we call displacement ventilation, where you use the stack effect and it brings outside and it moves it up through the inside and out, and we had fairly good ventilation. So, you know, natural ventilation, hot new topic. That's what we had for a long time. And then this fella came along because he'd been at the party, the keg party, and they came up with a new idea. This is Willis Carrier, and he said, well, why don't we air condition buildings? And that allowed us, you know, in the mid-50s, early century, to build buildings that we actually closed off. And we really had the inside invented then. And we had to have air to breathe. And, you know, we liked the indoors so much that we started spending like 90% of our time inside. How many of you work in buildings? Raise your hand. How many of you live in houses? Raise your hand. Okay, so, you know, we built the indoors. We planned, you know, the good designers among us said we need fresh air. So we designed fresh air intake into schools. I recall being on a Michigan School Business Officials Task Force, Facilities Task Force in the late 70s, early 80s, where we put out a manual after the energy crunches that said, shut off your outside air. Here's a lot of different methods to shut your outside air off because it's expensive and it can save you a lot of energy. And then the teachers, you know, always needing shelves and blocking off return air and so forth. So, you know, we're learning to live in this inside business. We had to populate the inside, so we used machines to make lots of chemicals. We aren't really good at maintaining our inside, so we often see things like that. And then, you know, if all else fails, I got my green stuff and it'll kill anything. So just let me at it. You know, and so, you know, thinking back on our suitcase that now has wheels, we started to do some studying. We continue to do some studying. And doctors, these are health reports, graphs from this report that was put out earlier this year. Thank you, Joyce, for sharing it. But, you know, you can look at these graphs, and indoor air pollution or quality of indoor air is like 30% on everybody's radar. It's that important. You know, 30% of people are complaining about it. 30% of people say it's really important, that if we don't have it, then we're going to be harming ourselves. Surprise, surprise. But, you know, at home on a residential basis, we know this stuff. You know, we did invent the wheels on the suitcase. So, you know, we clean our air, we clean our filters, we vacuum weekly, or however, we keep a clean, healthy house, or we try to. But we also buy stuff all the time, and everything we buy pretty much has chemicals in it. So, you know, understand we live in a chemical-based world now. So putting indoor air quality into perspective, many buildings have indoor air quality, environmental quality problems. We spend about half our time in the buildings we work in. Most indoors, pollutants are usually more prevalent inside than they are outside, although that's not getting so good in some places. And one of the main things from a business point of view, I've been an environmentalist for, I don't know, 40 plus years. And when I came to the Chrisman Company, I actually fit in fairly well because, I mean, I used to be, you know, on the fringe. And now I'm mainstream. I shaved my beard a little bit, but I worked really well with the CEO of the Chrisman Company, Steve Rosnowski, because he looked at everything from an accounting business point of view. I looked at everything from a environmental point of view, and our minds melded, if you will. And this building is one example of that, where this is a very healthy building, and the main impact that it has is on salaries, okay? I mean, if you look at any organization, the cost to operate it from an energy point of view or a maintenance point of view, or even rent the space, is minimal in the 80 to, 20% or less of the cost of actually using the space. People money. So anything you can do to increase the effectiveness, happiness, healthiness of the people in a space, the better you are. So, Russ, could I use you as an example? No, I won't. So this fella right here, he's putting out heat. About 100 watts, 100-watt light bulb of electricity is what we're putting out, sitting down like you are now. We breathe out moisture. We have odors. We breathe out CO2. It's a natural thing. We breathe it out. Luckily, trees breathe it in. We have particulates that we carry in from outside on our shoes, lint shaking off, all kinds of particulates. We breathe and we live. I mean, I don't know if you guys have seen some of these pictures of the bacteria that makes up a human, or that's on the surface square inch of skin, but it's billions. So we bring those into our space. And then we wear chemicals, we have scents, deodorants, shampoos, and so forth. So people are the ones that pollute our inside, indoor air. So being good at what we do, witness the suitcase, we come up with standards. And we say, well, we got to have fresh air. It's kind of a no-brainer, but we better tell people how much fresh air we need. So the ASHRAE standard is basically ASHRAE 62 is basically the standard for ventilation that we use in America mainly, and Canada, and then they have other versions in other westernized areas of the world. And we've decided, ASHRAE's decided, that about 1,000 parts per million of carbon dioxide is a good yardstick to measure the freshness of the air. Or I think of it as the stuffiness quotient. And that equates to about 15 CFM per person. And more of that puts you to sleep. Remember when you were in school, in elementary school, and you had lunch, and you had play recess, and then you came into the building, and you sat down at your desk, and after a little while, you started to feel drowsy. That's because you didn't have enough CO2. You had too much CO2 in there. So what can we do to make the healthy choice the easy choice? And there are some things we can do. The original attempts at ventilating inside was to bring in fresh air, and actually this building has all three of the types of ventilation systems that I'm going to show you. But this is what we call overhead air distribution. It's what you see here. It's most common. You have the air grills. You have a return air grill there. Sometimes it's in the ceiling. And it does a pretty good job of maintaining a uniform temperature and ventilation throughout the space. So it's kind of like this one right here. That's all the stuff we breathe out, carry in, and it's swirling around us quite evenly. We did a good job of that. And then we decided, displacement ventilation, kind of like we used to have, in the old days. And then we bring air in at the bottom of the space, and the ventilation comes in here, the freshest air comes in here, and then it rises up. The heat of our bodies causes the air to rise and the equipment, and it carries the pollutants away from us and out, as opposed to this, where we're breathing out all of our stuff that we just saw, and it's being pushed down back at us right now. And it's mixing up really good, and then it's being carried out, and it's being cleaned in the air filters and being mixed with outside air to dilute the carbon dioxide in the air. So, this is a good system. It's, I always say to designers or people I talk to, look at the vernacular architecture of the space that you're in. And, displacement ventilation was what we used for a long time. Then we also have a new one called underfloor air distribution, and the second through the sixth floor of this building has underfloor air distribution, which is basically, an underfloor zone, and it allows you to control the temperature of your space to some extent. You have a low volume swirl of air that goes up, and that basically brings the it's typically cool air up at the lowest level through the breathing zone and back out. Again, cleaning the air. Then we've got this newfangled thing called natural ventilation. We rediscovered those thingamajiggies on the top of the houses and the buildings. And they helped us with the stack effect, which is basically the bottom line theory of what moves air through our buildings. And then we also have mixed mode ventilation, which is the bringing in ventilation from the outside and mixing it and taking it out. But remember the suitcase. We're dealing with Mother Nature again, and we need to be aware that Mother Nature has her own temperament, and we need to plan for that. And then the architects and the designers and the engineers build the building, and everyone moves in, and most people, the standard is 80%, 80% of the people are comfortable, and the other 20% are usually fairly verbal. And that's the standard. 80% of the people, ASHRAE standard is 80% of the people are comfortable. That's the goal, which inversely is 20% of the people are uncomfortable. And that's a really high goal. Most buildings don't come to it. 50, 60% of people are happy. But don't worry, keep calm. Maintenance man will fix it. So we move to the inside. We now design for the inside. One of the biggest things that doesn't happen is we then don't maintain the inside. And I teach the building operator certification program, and some of these next slides come from that. But again, it's a no-brainer. Think of the suitcase with the wheels. We need to keep space dry. We need to keep it clean, comfortable, control pollutants, add adequate ventilation. If we do those 5 things, we'll tend to have good indoor air. This is a CO2 monitor from a typical school classroom. That you can see that the CO2 outside, or the CO2 at the beginning of the morning was the same as outside. Then during the day, kids started breathing out, and it went up to, it's probably ventilation threshold, where the ventilation started opening up to maintain 800 parts per million. And then we went out for lunch, and then we came back in, and you can tell when a building is occupied by the CO2. In fact, we operate this room based on a CO2 occupancy schedule. So I've got a CO2 set point at 550, and that basically, if it's below 550, I know it's unoccupied. When we get about 4 or 5 people in here, we get up to 550. And then it changes to occupied, and then we've got a CO2 ventilation program that maintains it at under 800 parts per million. And we hardly ever need to increase ventilation because the design does that. So CO2 is kind of, there's a lot of different chemicals and variables we can measure. CO2 is one of the easiest to measure and to control for, and therefore it's used by building operators as kind of the main yardstick to see how healthy is our indoor air. So you want to keep things below 1,000 parts per million. You start to approach that when you get crowded spaces, low ventilation rates. Even at elevated levels, CO2 is not like a poison or anything like that, you know. All it's going to do is put you to sleep, as opposed to carbon monoxide, which will also put you to sleep, but you probably won't wake up. How many architects, designers do we have in the room? Raise your hand. So we all have quite a few. You've probably heard of MERV ratings. MERV stands for, and I've never been able to remember that, so I actually had to write it down here, minimum efficiency reporting value. That's what a MERV is. Trust the engineers, you know, and the scientists. So in LEED buildings, we try to put in filters that are a minimum of 13 MERV, and that basically is a small enough aperture